Hello, in this lecture we'll find out the values of line segments X and Y. In the drawing we have square DBEF. The square is inside the right triangle ABC. You know that one side of square DEBF is equal to 1 unit, that is to say DB equals to BF equals to 1 unit. The hypotenuse of square of triangle ABC equals to AC equals to 3 units, and we want to find out the values of line segment AD that equals to Y and line segment FC that equals to X. Okay, so we know that the opposite sides of a square are equal to each other. That is to say, side DE equals to side BF. In square DEBF, in square DBEF, we know that BE is parallel to BF. According to the rule, the opposite sides of a square are parallel to each other. And we also know that BC is a straight line because BC is one side of the right triangle ABC. Therefore, BC is absolutely a straight line. BC is a straight line. And BF is part of the straight line BC. And we know that BF is parallel to DE. Therefore, if we know that the part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to that straight line. So we know that BF is parallel to DE, therefore BC, that is the straight line itself, must be also parallel to DE. So BC, that is a straight line, must be also parallel to DE, because if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to that side, to that straight line. So we know that BF is parallel to DE, therefore the straight line itself BC must be also parallel to DE. So we know that BC is parallel to DE, and according to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I'll repeat on rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. That is to say, those two corresponding angles that are located between the parallel lines DE and BC will be equal to each other according to rule number 1. So actually this angle, that is angle AED, must be equal to this angle, that is actually angle ECF, according to rule number 1, that those two corresponding angles that are located between the parallel lines DE and BC are equal to each other. So if we define angle AED as theta, if angle AED equals to theta, then from this equation we will get that angle ECF also equals to theta. Angle ECF also equals to theta. And we also have rule number 2 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Side AB is one side of the right triangle ABC, therefore side AB, it is absolutely a straight line. AB is a straight line. Okay, we know that side AB is a straight line, so if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. So if we define this angle as angle X, then at point D on this side, X plus 90 degrees must be equal to 180 degrees. This is actually according to rule number 2. I repeat again. On this side of the straight line AB at point D, the sum of the angles must be equal to 180 degrees according to rule number 2. Which angles we have at this side at point D? We have 90 degrees plus X, and the sum of those two angles must be equal to 180 degrees. Again, X plus 90 degrees must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we will get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So if angle X is a right angle, then triangle ADE is a right triangle. Triangle ADE is a right triangle. Likewise, we know that BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So we can write down that BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if we define this angle as angle Y, then 90 degrees plus angle Y must be equal to 180 degrees. 90 degrees plus angle Y must be equal to 180 degrees according to rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we subtract 90 degrees from this equation and we get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle Y is a right angle, that is to say it equals to 90 degrees. And if angle Y is a right angle, then actually triangle EFC is a right triangle. Triangle EFC is a right triangle, and we have already found out that triangle ADE is also a right triangle. So we have here two right triangles with triangle ABC. This is actually also a right triangle. We have three right triangles, and we will focus on the right triangle, triangle ADE. On the right triangle, triangle ADE. We know that tangents theta equals to AD over DE. I repeat again, on the right triangle, triangle ADE, we know that triangle theta equals to AD over DE. And we know that all the sides of a square are equal to each other, so DB equals to 1, BF equals to 1, so DE will be also equal to 1 unit, and EF also equals to 1 unit. So actually, tangent alpha in triangle ADE that equals to AD over DE, it is actually equals to AD, that is Y, over DE, that is 1. In conclusion, we actually found out that tangent alpha, according to equation number 1, in triangle ADE equals to Y, tangent theta equals to Y, and in the next step we'll focus on the right triangle, triangle EFC, this right triangle. In the right triangle, triangle EFC, we know that tangent theta equals to EF over FC. I'll repeat again. On the right triangle, triangle EFC, we know that tangent theta equals to EF over FC. EF equals to 1, FC equals to X. So in conclusion, we found out that according to equation number 2, in triangle EFC, tangent theta equals to 1 over X. I repeat again. According to equation number 2, in the right triangle, triangle EFC, tangent theta equals to 1 over x, and according to equation number 1, tangent theta equals to y, so we have two different expressions for tangent theta. So we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, so we write down that tangent theta equals to tangent theta. So actually, tangent theta according to equation number 1 equals to y, and it must be equal to tangent theta according to equation number 2 that equals to 1 over x. So in conclusion, we found out that according to equation number 3, 1 equals to y equals to 1 over x. Here we will multiply equation number 3 by x, and we will get that y times x equals to 1. By the way, it is allowable to multiply by x because x is a length, and the length can never be 0. It is length of one side of a triangle. It must be a positive number, therefore it is allowable to multiply the equation by x. So we found out that y times x equals to 1. So this equation means that y and x are two inverse numbers. X is the inverse number of y, and y is the inverse number of x. That is to say, if x equals to 5 units, then y equals to 1 over 5. And in the next step, we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, and the square of the hypotenuse is AC squared. AC squared equals to AB squared plus BC squared. I repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to AB squared plus BC squared. So we know that AC equals to 3 units. It is given 3 units. It is given us in the question. So AC squared is 3 squared. 3 squared is 9. 9 equals to AB squared. AB equals to y plus 1, therefore AB squared will be equal to y plus 1 squared plus BC squared. BC equals to x plus 1, so BC squared will be equal to x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4, and we will get that according to equation number 4, y plus 1 squared is y squared plus 1 plus 2y plus x plus 1 squared is x squared plus 1 plus 2x, and it equals to 9. according to equation number 3, we know that y equals to 1 over x. So we'll substitute y by 1 over x in equation number 4, and we get that according to equation number 4, y squared is actually y is 1 over x, so y squared is 1 over x squared plus x squared. 1 plus 1 is 2, plus 2 plus 2x plus 2x equals to 9. It's actually 2x plus x squared again we have here y squared plus 2y plus 2 plus x squared plus 2x equals to 9. And we know that y equals to 1 over x. According to equation number 3. So we substitute y by 1 over x, and we'll get that according to equation number 4, y squared is 1 over x squared plus 2y is actually y is 1 over x, so it is actually plus 2 over x plus 2 plus x squared plus 2x equals to 9. And so here we will organize the numbers. We get that x squared plus 1 over x squared plus 2 plus 2x plus 2 over x equals to 9. Here x squared plus 1 over x squared plus 2 is x plus 1 over x squared. And here we will take a common factor 2 from those two expressions, and inside the brackets we will have here x plus 1 over x, that equals to 9. We will subtract 9 from this equation, equation number 4, and we will get that x plus 1 over x squared plus 2 times x plus 1 over x minus 9 equals to 0. Here we will define t as x plus 1 over x. So we will substitute x plus 1 over x in equation number 4 by t, and we will get here x plus 1 over x squared is t squared plus 2 times x plus 1 over x is 2t minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. X is actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. And in our specific expression, we know that a equals to 1, b equals to 2, and c equals to minus 9. So according to the special formula for x, our variable, our missing variable is t, so x equals to t. So we get that t equals to minus b, and minus b is 2, so minus b is minus 2, plus minus square root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, 4 times 1 is 4, so minus 4 times minus 9 is plus 36 over 2a. A is 1, 2 times 1 is 2. So in conclusion, we got that t equals to minus 2 plus minus square root of 4 plus 36 over 2. 36 plus 4 is 40, so t equals to minus 2 plus minus square root of 40 over 2. So we know that 40 is 4 times 10, and the square root of 4 is 2, so we write it down that t equals to minus 2 plus minus 2 times square root of 10 over 2. Minus 2 over 2 is minus 1. So t equals to minus 1 plus minus 2 over 2 is 1. So it is plus square root of 10. So here we have two solutions that are possible for t. The first solution is that t equals to minus 1 plus square root of 10. And the second solution for t is that t equals to minus 1 minus square root of 10. We will focus on the second solution, that t equals to minus 1 minus square root of 10. T, according to our definition, is x plus 1 over x that equals to minus 1 minus square root of 10, and x is length because it's the length of one side of a triangle. Therefore it must be a positive number. That is to say, x plus 1 over x is a positive number, while minus 1 minus square root of 10 is a negative number, and a negative number can never be equal to a positive number. Therefore this solution is not possible. We cancel this solution, it is not correct, and we left only with the solution that t equals to minus 1 plus square root of 10. T is x plus 1 over x, that equals to minus 1 plus square root of 10. Here we will multiply this side of the equation by x, and then we will divide it by x. We'll multiply x by x, and then we will divide it by x in order to overcome the factor with 1 over x, and we will get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to x times square root of 10 minus 1. Here we will subtract from this equation x times square root of 10 minus 1, and we will get a quadratic equation that states that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1, and the solution for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So x equals to minus b, b equals to minus square root of 10 minus 1, so minus and minus is plus. So in conclusion, we got that minus b equals to square root of 10 minus 1, and plus minus b squared. B squared is square root of 10 minus 1 squared, minus 4 times a times c. A is 1, c is 1, so it is actually minus 4 over 2a. A is 1, so 2 times 1 is 2. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus, here we have inside the root square root of 10 minus 1 square, so it is square root of 10 square is 10, plus 1 minus 2 times square root of 10 times 1 minus 4, all divided by 2. So we will get that, according to this equation, x equals to square root of 10 minus 1 plus minus Here we have 10 plus 1 is 11, 11 minus 4 is 7, so it is actually 7 minus 2 times square root of 10, all divided by 2. Okay, and so we have here two solutions for x, and what is the value of 7 minus square root minus 2 times square root of 10? 7 is 5 plus 2, so it is 5 plus 2 minus 2 times square root of 10. Square root of 10 is equal to square root of 5 times square root of 2, so it is actually 5 plus 2 plus square root of 5 times square root of 2, and 5 is actually equal to square root of 5 square, plus 2 is 2 square root of 2 square, minus 2 times square root of 5 times square root of 2. Actually, this expression is very similar to the algebraic identity that says that a minus b square equals to a square plus b square minus 2ab. Here a is square root of 5 and b is square root of 2, so it will be square root of 5 minus square root of 2 square. So actually we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. So we will substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, and we will get that x equals to square root of 10 minus 1 plus minus, and instead of 7 minus 2 times square root of 10, we will write down square root of 5 minus square root of 2 square, all divided by 2. So we will get that x equals to square root of 10 minus 1 plus minus. Here we have square and root, and the square cancels the root, and we left only with square root of 5 minus square root of 2, all divided by 2. So we actually found out that x equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. This is the first solution that is possible, and the second solution that is possible is x equals to square root of 10 minus 1 minus square root of 5 plus square root of 2 over 2. We continue with this solution, and we'll substitute square root of 10 by square root of 5 times square root of 2, because square root of 5 times square root of 2 equals to square root of 10, and we get that x equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. So we got that x equals to, we take square root of 5 as a common factor, and we inside the brackets we will have here square root of 2 plus square root plus 1, and here we will have minus square root of 2 plus 1 all divided by 2. Here we will take square root of 2 plus 1 as a common factor, and we will get that x equals to square root of 2 plus 1 is a common factor, and inside the brackets we will have from here square root of 5, and from here we will have minus 1 over 2. So in conclusion, we found out that the first solution for x is x equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and we'll find out also the second solution for x, and we'll get that again we will substitute square root of 10 by square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 all divided by 2. So actually x equals to, here we will take square root of 5 as a common factor, and inside the brackets we will have here square root of 2 minus 1, and it will be plus square root of 2 minus 1 over 2. Here we will take square root of 2 minus 1 as a common factor, and we will get that x equals to square root, we will take square root of 2 minus 1 as a common factor, and inside the brackets we will have here square root of 5, and here we will have plus 1 all divided by 2. So the second solution is square root of 2 minus 1 times square root of 5 plus 1 over 2. So this is actually x2, and the first solution is x1. And we will multiply the two solutions of the quadratic equation x2 times x1. So x2 times x1 will be equal to x2 times x1, that are the two solutions of the quadratic equation. The quadratic equation has two roots, or two solutions. So x2 times x1, or x1 times x2. x1 is square root of 2 plus 1 times square root of 5 minus 1 over 2 times x2. x2 is square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So we will get that x2 times x1, that is the multiplication of the two solutions of the quadratic equation. Here we have 2 square plus 1 times 2 square minus 1, and according to the algebraic identity that a plus b times a minus b equals to a square minus b square, we will get that the value of square root of 2 plus 1 times square root of 2 minus 1, here a equals to square root of 2, so square root of 2 square is 2 minus b square. b equals to 1, so b squared is 1 square, 1 square is 1, so it is minus b squared is minus 1, and we have here square root of 5 minus 1 times square root of 5 plus 1, and according to this algebraic identity, it equals to a squared minus b squared. A is square root of 5, so square root of 5 squared is 5, minus b squared. B equals to 1, so b squared is 1 square, 1 square is 1, so minus b squared is minus 1, all divided by 2 plus 2 is 4. So we got that the multiplication of x1 by x2 equals to 2 minus 1 is 1, times 5 minus 1 is 4, over 4, and 1 times 4 is 4, and 4 over 4 is 1. So we found out that the multiplication of x1 by x2 is equal to 1. That is to say, x1 is the inverse number of x2 and x2 is the inverse number of x1. That is to say, if x1 equals to 5, then x2 will be equal to 1 over 5. So that, and according to equation number 3, we know that x times y equals to 1. That is to say, x and y are also two inverse numbers, and that is to say, if we multiply x by y, we will get 1. It means that x is the inverse number of y and y is the inverse number of x. Or you can see it also that as y equals to 1 over x. And so actually x1, y1 is the first solution. We know that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the value of x1. And the value of y1 will be equal to actually to x2. Why? Because we know that x2 times x1 equals to 1, and it is in the equation number 2, x times y equals to 1. So y1 will be equal to x2. Why? Because x2 times x1 equals to 1, and we also need to get that x1 times y1 also will be equal to 1. Therefore, y1 will be equal to x2. That is to say, it will be equal to square root of 2 minus 1 times square root of 5 plus 1 over 2. And because we already found out that x1 times x2 equals to 1, and if we multiply x1 by y1, we must also get 1. So y1 must be equal to x2 in order that the multiplication of x1 by y1 will give us 1. So this is the expression for x1 and y1. And x2 equals to square root of 2 x2 and y2 is the second pair of solutions. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And because of the fact that x2 times x1 equals to 1, y2 must be equal to x1. Why? Because x1 times x2 equals to 1, and x2 times y2 must also equal to 1 according to equation number 3. So y2 will be equal to x1. Okay? Why? Because we will get that x1 times x2 equals to 1, and this is what equation number 3 demands. It demands that x times y will be equal to 1, and we'll get that x2 times y2 indeed equals to 1. So y2 will be equal to x1. That is to say, it will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2. So actually we got here x2 and x1. Actually x2 and y2, it is actually exactly x2 and x1, and we know that the multiplication between x2 and x1 will give us 1, and that is exactly what equation number 3 demands, that x2 times y2 will be equal to 1, and because of the fact that y2 equals to x1, so we have here x2 times x1, and indeed we know that x2 times x1 equals to 1. So the first pair of solutions, it is actually thus square root of 2 minus 1 times square root of 5 plus 1 over 2, that is x2, and y2, it is actually square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay? And again, we know that x2 times y2 will be equal to 1, and this is okay. This is exactly what equation number 3 demands. And also we know that x2 times y2 will give us 1 according to exactly what equation number 3 demands. That the multiplication between x and y will give us 1, and indeed x1 times y1 equals to 1, and x2 times y2 equals to 1, because of the fact that we have already found out that x1 times x2 equals to 1, and here x1 y1, it is actually x1 x2, and here x2 and y2, it is actually x2 and x1, and we know that the multiplication of x2 and x1 will give us 1. So that is the solution. The two pairs x1 and y1 is the first pair of solution, and the second pair of solution is x2 and y2. And that is the answer to the question. Now I'll summarize the lecture. Actually, we wanted to find out the value of line segment X, that is FC, and line segment Y, that is actually AD. Okay? And we know that we have here square BDBEF, that one side of it is equal to 1 unit, and the square is inside the right triangle ABC. We know that the hypotenuse of the right triangle ABC equals to 3 units, AC equals to 3 units, and we want to find out the values of X and Y. So first of all, we know that all the sides of the square are equal to each other, so all of its sides will be equal to 1 unit. And we know that also that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. I'll repeat again. In square DEFB, we know that DE is parallel to BF because of the fact that the opposite sides of a square are parallel to each other. And we also know that BC is one side of the right triangle ABC, therefore it is absolutely a straight line. BC is a straight line, and we know that part of the straight line BC that is to say BF is parallel to DE. So if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to that straight line. So we know that BF is parallel to DE, therefore BC must be also parallel to DE because of the fact that BC is the straight line itself, and if you know that part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to that straight line. So if BF is parallel to DE, then BC also must be parallel to DE. So we can write down that BC is parallel to DE, and according to rule number 1, corresponding angles between parallel lines are equal to each other. Those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, that is to say DE is parallel to BC. Therefore, according to rule number 1, those two corresponding angles that are located between the two parallel lines DE and BC will be equal to each other. That is to say, angle AED equals to angle ECF according to rule number 1. So if we define angle AED as theta, then from this equation we will derive that angle AECF also equals to theta. So those two angles are both equal to theta. And then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that AB is one side of the right triangle ABC, therefore it is absolutely a straight line. AB is a straight line, and according to rule number 2, if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. So this angle that is 90 degrees plus this angle that we will define as angle X, the sum of those two angles must be equal to 180 degrees. That is to say, X plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtracted 90 degrees from this equation, and we got that angle X equals to 180 degrees minus 90 degrees, that is to say it equals to 90 degrees. So we found out that angle X is a right angle, so we substituted angle X by a right angle. So if this angle is a right angle, angle ADE is a right angle, therefore triangle ADE is a right triangle. Likewise, we know that BC is one side of the right triangle, triangle ABC, therefore BC is absolutely a straight line. BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees plus this angle that is defined as angle Y must be equal to 180 degrees according to rule number 2. 90 degrees plus angle Y must be equal to 180 degrees according to rule number 2. Here we subtracted 90 degrees from this equation, and we found out that angle Y equals to 90 degrees. This angle EFC that equals to Y equals to 90 degrees. So if angle EFC equals to 90 degrees, then triangle EFC is a right triangle. So those two triangles are right triangles, and triangle ABC is also a right triangle. Then we focused on the right triangle, triangle ADE. In this right triangle, we know that tangent theta equals to AD over DE. Tangent theta equals to AD over DE. But AD equals to Y according to what is given us in the question, and DE equals to 1. So tangent theta, in conclusion, equals to Y. Then we focused on the right triangle, triangle EFC. Here, tangent theta equals to EF over FC. In the right triangle EFC, tangent theta equals to EF over FC. EF equals to 1. FC equals to X. So in conclusion, we found out that in triangle EFC, according to equation number 2, tangent theta equals to 1 over x. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. So, according to equation number 3, tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 2, that is actually 1 over x. That is to say, according to equation number 3, y equals to 1 over x. We multiplied the equation number 3 by x, and we found out that y times x equals to 1. That is to say, y and x are two inverse numbers. Y is the inverse numbers of x, and x is the inverse number of y. Okay, so if y equals to 5, then x must be equal to 1 over 5. Okay, then we focused on the right triangle, triangle ABC. In the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, and the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. AC equals to 3 units. So AC squared is 3 squared. 3 squared is 9. 9 equals to AB squared. AB is y plus 1. So AB squared is y plus 1 squared plus BC squared. BC is x plus 1. So BC squared is x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. We open the brackets on this side of equation number 4, and we found out that y plus 1 squared is y squared plus 1 plus 2y plus x plus 1 squared is actually x squared plus 1 plus 2x, and it equals to 9 according to equation number 4. And according to equation number 3, we know that y equals to 1 over x. So we arranged the equation number 4 in this way, that y squared plus 2y plus 2 plus x squared plus 2x equals to 9. And then we substituted y by 1 over x, because according to equation number 3, y equals to 1 over x. And we got that y squared is 1 over x squared, plus 2y is plus 2 times 1 over x, plus 2 plus x squared plus 2x equals to 9. So here we have x squared plus 1 over x squared plus 2 plus 2x plus 2 over x equals to 9. X squared plus 1 over x squared plus 2 is x plus 1 over x squared. And here we took a common factor of 2 from these expressions, and inside the brackets we get x plus 1 over x, that equals to 9. We subtracted 9 from equation number 4, and we got that x plus 1 over x squared plus 2 times x plus over x plus 1 over x minus 9 equals to 0. Here we defined t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition, and we substituted x plus 1x by t, and we got here that according to equation number 4, t squared plus 2t minus 9 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific expression, in our specific quadratic equation, we know that a equals to 1, b equals to 2, and c equals to minus 9. And the variable that we are looking for is t. Okay? So we put the data inside the formula for x equals to t, so t equals to minus b, b is 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times ac, a is 1, c is 9, so minus 4 times ac is minus 4 times minus 9 is plus 36, so inside the root we have 4 plus 36, all divided by 2a, that is 2. Then we found out that t equals to minus 3 plus minus 36 plus 4 is 40 over 2. Here 40 is 4 times 10. Square root of 4 is 2, so in conclusion we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here we divided this equation by 2, this side of the equation by 2, and we got that t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so in conclusion we found out that t equals to minus 1 plus minus square root of 10. So we have here two solutions that are possible. The first solution for t is t equals to 1 plus square root of 10, and the second solution is t equals to, it is actually t equals to minus 1 plus square root of 10, and the second solution is t equals to minus 1 minus square root of 10. But what is t? T, according to our definition, is x plus 1 over x. And x is length, is the length of one side of a triangle, therefore it must be a positive number. Therefore x plus 1 over x must be a positive number, while minus 1 minus square root of 10, it is a negative number, so a positive number can never be equal to a negative number, and therefore this possibility is cancelled, it is not true, and we left only with the possibility that t equals to minus 1 plus square root of 10. We know that t equals to x plus 1 over x according to our definition, so x plus 1 over x equals to minus 1 plus square root of 10. Here we multiplied x by x and then we divided by x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x, and we got that x squared plus 1 equals to x times square root of 10 minus 1. So we subtracted x times square root of 10 minus 1 from this equation, and we got the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a, so x equals to minus b. Here minus and minus is plus, so in conclusion we found out that b equals to square root of 10 minus 1 plus minus b squared. B squared is square root of 10 minus 1 squared, minus 4 times ac. A is 1, c is 1, so it is minus 4 times 1 times 1 is minus 4. So in conclusion we found out that x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 squared minus 4 over 2. So x equals to square root of 10 minus 1 plus minus. Inside the brackets we have square root of 10 minus 1 squared, that is actually square root of 10 squared, that is 10, plus 1 squared, that is 1, minus 2 times ab, that is minus 2 times square root of 10 times 1, that is actually minus 2 times square root of 10, minus 4 over 2. Here we have 10 plus 1 is 11, and 11 minus 4 is 7. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus 7 minus 2 times square root of 10 over 2. So what is the value of 7 minus 2 times square root of 10? The value of 7 minus 2 times square root of 10 that is inside the root, it is actually 7 is 5 plus 2. And here we have also minus 2 times square root of 2, 2 times square root of 10. So it is 7 is 5 plus 2. And we substituted square root of 10 by square root of 5 times square root of 2. And here we took, and we know that 5 is square root of 5 square and 2 is square root of 2 square. So we substituted 5 by square root of 5 square and we substituted 2 by square root of 2 square. And we got this expression. Here we took square root of 5 as a common factor from this expression, and we have here square root of 5 plus square root of 2, square root of 5 square plus square root of 2 square minus 2 times square root of 5 over square root of 2 over 2. This expression is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. So we can substitute this expression by a minus b square. A is square root of 5, b is square root of 2, so a minus b square will be equal to square root of 5 minus square root of 2 square. And we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 10 square. So we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. We did it and we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 square. Again, we substituted this expression by this expression. We got this expression. And here we have the square cancels the root and we left only with square root of 5 minus square root of 2. So in conclusion we found that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2. Repeat again that the root cancels the square and we left only with square root of 5 minus square root of 2 over 2. So here we have two solutions that are possible. The first solution is x equals to square root of 10 minus 1 plus square root of 5 minus 2 over 2. And the second solution is x equals to minus square root of 5 minus 1 minus square root of 5 plus square root of 2 over 2. So we continue with this solution. Here we substituted square root of 10 by square root of 5 times square root of 2. And then we took square root of 5 as a common factor. Inside the brackets we have square root of 2 plus 1 minus square root of 2 plus 1 over 2. Here we took square root of 2 plus 1 as a common factor, and inside the brackets we left with square root of 5 minus 1 over 2. So the first solution for the quadratic equation is x1, that equals to square root of 2 plus 1 over square root of 5 minus 1 over 2. That is x1. And x2, the value of x2 is square root of 2 minus 1 times square root of 5 plus square root of 2 over 2. We substituted square root of 10 by square root of 5 times square root of 2 minus 1 times minus square root of 4 plus minus square root of 5 plus square root of 2 over 2. So here we took square root of 5 as a common factor. Inside the brackets we have square root of 2 minus 1. And what is left is actually square root of 2 minus 1. So we took square root of 2 minus 1 as a common factor. And we found out that x2, the second solution for the quadratic equation, is minus 2 minus square root of 2 minus 1 times square root of 5 plus 1 over 2. So we have two solutions for the quadratic equation, x1 and x2. And we multiplied the two solutions of the quadratic equation. That is to say, we multiplied x1 by x2. And we got that x1 times x2, that is the two solutions of the quadratic equation, equals to the multiplication of those two expressions, and the multiplication of those two expressions will give us 1. Why? Because square root of 2 plus 1 times square root of 2 minus 1, we'll calculate it according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. Here a is square root of 2, so a squared is square root of 2 squared. Square root of 2 squared is 2 minus b squared. B is 1. B squared is 1 squared. 1 squared is 1. So minus b squared is minus 1. So in conclusion, we found out that the multiplication of those two expressions is 2 minus 1, that is actually 1. And then we have to multiply square root of 5 minus 1 times square root of 5 plus 1, according to the same rule that a plus b times a minus b equals to a squared minus b squared. A is square root of 5. Square root of 5 squared is 5. Minus b squared. B is 1. B squared is 1 squared. 1 squared is 1. So it is minus 1. In conclusion, the multiplication of those two expressions is 5 minus 1. So 2 minus 1 is 1. 5 minus 1 is 4. 1 times 4 is 4. So it is 4 over 2 times 2, that is also 4. And 4 over 4 is 1. So we found out that the multiplication of the two solutions for x gives us 1. That is to say, x1 is the inverse number of x2 and x2 is the inverse number of x1. Exactly according to equation number 3, we also know that x times y equals to 1. It means that x is the inverse numbers of y and y is the inverse number of x. So actually, after we know that x1 equals to square root of 2 plus 1 over square root of 5 minus 1 over 2, that is actually x1, we know that y1 is the inverse number of x1. Y equals to 1 over x. And x1 times x2 is 1. So if we have here x1, then y1 must be equal to x2 because of the fact that x1 times x2 equals to 1 and x1 times y1 must be also equal to 1. Therefore y1 must be equal to x2. Why? Because their multiplication must be equal to 1 and x1 times x2 equals to 1. So if y1 will be equal to x2, then x1 times y1 will be also equal to 1. So y1 will be also equal to x2. Okay? And then when we have the second solution for x, that is x2, then y2 must be equal to x1. Why? Because we know that x1 times x2 equals to 1 and x2 times y2 must be also equal to 1. In order that x2 times y2 will be equal to 1, y2 must be equal to x1, and in this way we'll get that x2 times y2 to this x1 will be equal to 1. So here y2 is actually x1, and we will get that x2 times y2 to this x1 will be also equal to 1, exactly what equation number 3 demands, that x times y will be equal to 1. So if x1 times y1 will be equal to 1, and also x2 times y2 will be equal to 1, exactly according to the demands of equation number 3, that x times y must be equal to 1. So those are the two solutions for x and y. The first pair of solution is x1 and y1, and the second pair of solution is x2 and y2. And as you can see here, x1 times y1 equals to 1, exactly according to the demands of equation number 3, x2 times y2 also equals to 1, exactly according to the demands of equation number 3. Okay, that is the solution to the question. Okay, thank you very much.